Hey, g'day, it's Prezzo. Welcome back to the shop today. Now, this is part 2 of a series that I started on manufacturing a pair of Art Deco inspired wall sconces. Now, a wall sconce is just a light fitting that you screw to the wall, and I've started a playlist on this series, and the link's up above there now, but you can also have a look in the description. You can find it there too. Now, in this part 2, we're going to make some of the decorative elements that go on the top and the bottom of this light fitting. And the decoration in this wall sconce is important because it mimics that style that was apparent in the middle of the 1930s. This was a period in which craftsmen and designers truly cared about the appearance and the aesthetic of things that they were designing. And you could see this across all sorts of areas of society. So it was in architecture, it was in cars, it was in fashion, household items, you name it. It was all influenced by this Art Deco aesthetic. And the designers of the day borrowed very heavily from antiquity, they borrowed from modernistic styles, and this was all rolled out into these wonderful, wonderful products, which you can still get today, but it's becoming harder and harder to find something of any quality. And that's why I decided to make my own. But let's have a look at the drawing and let's check out what we're going to do today. Here's a 3D drawing of the design that I'm working to. Now, I always model these out in Autodesk Inventor just to ensure that the form is the way I want it, but also it allows me to check the geometry of all the parts and to make sure that everything is going to fit together when we're done. So the parts we're making today are these top and bottom covers. Now, they're identical and they're made of flat sheets of brass with an edge strip bent around and then soldered in place. Now, there's a second element that fits on top of that, and that's called, I've just called it a riser. Similar construction, but slightly different shape. These are the castings that we're going to do, but that's going to be in a later episode. So I've already done these top and bottom covers, but I did do the video as I went, and I'll show you that process later. But with these ones here, all I've done so far is I've cut out the brass sheet roughly. So there's one there. And you can see an outline that I've scribed on there, and I've just simply sawn that to the outside of that profile. Now, I did that on my little metal cutting bandsaw. It's a really great tool for cutting this 2mm thick brass sheet. And I also cut up all of the edge strips that are going to get bent around those forms. So that was all done on the same saw, but these have been milled to 11mm wide, just to ensure that they're parallel and that everything's going to lay down nice and neatly against that flat sheet of brass when we solder it together. Anyway, let's go over to the CNC mill. I'm going to start by prepping these parts so that I can screw them down to a fixture. These 4 rough cut blanks are going to get held down to a steel fixture in the CNC mill with M4 screws, and I want to drill a single hole in this part and use that to locate it while I drill the second hole in the CNC mill to make sure it lines up with the fixture. Okay, here's my little steel fixture. It's just a piece of 8mm thick hot rolled steel plate. I've clamped that down to the bed of the mill, and I've drilled 5 holes in this plate. Now, for the larger plates, which you can see I've already machined, I needed 3 holes to position those and hold them down tight. But for the smaller plate, this one here, I only need 2 holes. So all of the plates have a common center, which is this screw here. And then we're about to drill the hole for this center here. So I'm going to hold that down. Plates are a bit oversized, so I don't need to be too careful about whether I got the square or not. Now, with only 1 screw holding this, it would almost certainly rotate. So that's why we're using 2. I suppose I should really check it. Just want to get it fairly close. Okay, we'll drill that one. So I'll go ahead and do all 4, and then we'll come back and we'll machine this one. I'm using a 4-flute 6mm carbide end mill. So I'm just going to set my Z with the quill and then lock it, and then zero out the DRO on the machine controller. Now, I know that experienced CNC machinists are going to be looking at this and saying, oh, Mark, that thing's a toy. Well, yes and no. For me, in this workshop, it enables me to do things that I would otherwise have to do by hand, and you're never going to get the same consistency between parts when you do it that way. Now, I know some people are very good at it, but for me, I just like playing with this little machine. So there's our part, and I can get 4 of those that are going to be almost identical, and that took about, what, 5 minutes to machine that, a bit longer to do the fixture. But yeah, I think it's worthwhile to have some experience with CNC machinery these days in a home workshop, you know, whether that's a 3D printer, a laser cutter. At least one of those machines in the workshop makes your life a lot easier. There's 2 of those plates now off the CNC mill, and this is going to form a full assembly at a later stage, and it needs to be attached to this rectangular frame here, and it needs to stand up at right angles in that position there. Now at the moment I've got no way of attaching that, so I've cut up some brass stock here, and it's 60 millimeters long, and it's going to screw to the end of that rectangular frame there, and if we attach our decorative assembly to that, then we can take that off and put it back on again and do the full assembly of the whole light fitting. So I need to be able to attach that at right angles using silver solder, and just butting it together there is a bit awkward. It's sort of hard to locate it, it's hard to sort of get it side to side accurate. So what I want to do is cut a pocket in here, and I'm going to use the same fixture I used on the CNC mill, and I've prepared it by cutting a pocket here which is the same length as that piece of brass, and it's 2 millimeters deep relative to the plate. So we can screw the plate to that and stand it upright in the Bridgeport and cut the pocket. So let's go and do that now. With these edge strips, they need to be annealed now, and I need to be able to bend them around these brass plates. Now with the small one, I need to do that by hand around a mandrel, but on the large one I can use the jeweler's rolls, but I'll still anneal them anyway. So annealing is just a process of heating up the brass strip until it's red hot and then allowing it to cool. Now you can plunge it into cold water, but that has no effect on the annealing process, it just speeds up the process. So I'm just going to let these cool in air. So you just need like an even red heat. Got this mandrel here mounted in the bench, and it's got two diameters. The top one is smaller than the finished diameter that I need. The bottom one is the exact diameter. I'm going to bend it around the top one because it'll almost certainly spring back a bit. So I'm just going to clamp that on there. Alright, we'll just pull this around by hand. These strips are longer than I need. Yeah, that's springing back quite a bit. Yeah, if I put it on that bottom one, it's way too big. So what I'll do is I'll put this in the vise, just squish it a bit, maybe tap it around with a soft mallet and see if we can get that fitting better. I just took a bit of a squish in the vise and I've got that really close now. When I get this clamped, I'll be able to give it a few taps here and there to get it seated properly against the edge of that rebate. With these large plates, the edge strip can be a continuous radius all the way around, so I can use the jeweler's roll. And I've set this up so that the pinch rollers are the correct distance apart, so they'll grab that stock and pull it through. So they're gear driven and they will feed the stock through. The roller on the back here you need to adjust by trial and error. I'll just sort of set it roughly and we'll run this through and see if we get close. So that's quite a bit bigger than we need. And what you do is you flip it end for end, because there's always a straight bit just here that it can't roll to a radius. So you sort of keep flipping it. Alright, it's pretty good there now. And you just check it and then adjust that roller a little bit at a time till it matches. So we're still a way off there. Don't know if the camera can see that. Alright, getting pretty close. Okay, that sort of clicks into place now and it fits quite well all the way around. So I'll leave that one there. And what I found is if you do the next one at exactly the same setting, it'll bend it too tight. So I'm going to back it off about one full turn. Okay, again, got it really close, but it's going to need a bit of clamping and tapping and so on to get it perfect. Now that we've got these edge strips done, they fit pretty good, but not that good. And if I don't clamp that, things are going to move when we heat it up. So I do need to clamp that right on the very edge, which is quite awkward. So I'm going to need some sort of a clamp. I've only got two of them. I've only got one of these, and I'm not going to put that in an oxyacetylene flame. Oh, this. Perfect. Let's go and make 4 of them. See if we can put one of these together now. What I've done is I've cut some nicks all the way around that edge there, that mating surface, and I put a chamfer around the inside edge. Now we're going to put the silver solder on the inside, and I want that to run right through that joint and wet it all the way to the outside edge of that plate there. So I'll get this clamped up and then we'll see how we go. What we're looking for there is that silver solder is flashed right around the interior of that joint and hopefully penetrated through the outside. I'll get that cooled down and have a closer look. You sort of see that bright silver coming through the gap in the joint there. And when I go to polish this, it means that we won't have like a line that shows up after we've electroplated it. So I'll go and pickle this one. We'll do one of the big joints. Okay, same deal with this one. It's got 4 clamps, that's all. That went pretty good. We'll get that one cleaned up too. Alright, there's all of those parts out of the pickle now. There's a couple still in the pickle, but they're all done. And what I need to do now is to attach this rectangular plate to this pocket here. Now this is going to form the bracket or the main assembly point for this whole sub-assembly onto the rectangular frame. And the only thing I've got to locate that is just that pocket that I milled into that plate there. So it's a pretty good fit, but I'm not sure if that's going to be sufficient to, get that accurate. So I'll just show you what I had in mind. And just off camera, I trimmed the excess off the back of this plate here. You'll notice with these, I've left the material longer than it needs to be. And just as a general principle of fabrication, whether you're doing woodworking or metalworking, never cut your material to length unless you really have to. Once you cut it to length, you're committed. If you leave it long, you've got options. You can always trim it back. But in this case, you know, the chance of getting that rotationally aligned is just about nil. So it's better to leave it a bit long, cut it back later. So I've done that with this one here. And I'll just show you what I had in mind for doing the assembly. Well, this is what I had in mind now. These are fire bricks and they're not terribly accurate, and with a lot of messing around and repositioning and reorienting, I got these two surfaces here, so they're roughly perpendicular, or pretty close actually. So if I put a square on there, it's almost 90 degrees, and if I push my two pieces that I want to silver solder together up against those faces and check it with the square, it's pretty good. Not perfect, but very, very close. And I can do a little bit of bending and, you know, judicious filing and so on later on, and I should get that right. So I'm going to go ahead now and silver solder this joint, and we'll see how close we got. And I did put some nicks in those mating surfaces to allow the silver solder to run through. Probably should have preheated the bricks. That one's better. Everything's warmed up now. Okay, I'll go and cool that down, see how close we got. Well, I haven't pickled that one, and it worked pretty good. What I didn't realise is that this back edge of this brick here has got a slight dip in it, and the plate just pushed down just a fraction, and there's a little bit of a raised lip there, but that's okay because we're going to sand all of that surface off on the belt sander and get that dead flat and then polish it, because it's 2 millimeters thick. We got plenty of meat there to do that. As far as getting that square goes, let's see if you can see that. We're pretty good. Just going to try this again. I've sort of got a better arrangement of bricks, and I've weighted that plate down just so it doesn't move too much. See if we can get a better result this time. It's much better. You can see on the back there it's quite flat. Seem to keep square, and I've got a much better fillet of solder in there as well. So I'll do that for all of them. Well, just to finish up today's video, I thought I'd show you some of the parts. Now these are nowhere near finished, but I did go ahead and polish up one of these little risers here. So it's been trimmed off at the back, and I've done a preliminary polish on that. It's nowhere near finished, needs a lot more work. But the most interesting thing is that you cannot see the join between this top plate and this side strip. So the silver solder has penetrated really well there. The fit was really close, and the important thing is that when that's polished up, you cannot see that join. So when that's electroplated, that's going to look like a solid piece of brass or a casting. So, you know, I'm happy that that's worked out the way it has. And I also went ahead and I fitted one of the end plates to the rectangular frame. So that's just held on with a couple of countersunk head screws. And then later on there'll be a 3D printed part that goes in here, and we'll have pockets for all of the glass tubes. So that will locate them around this inside edge here. So that's worked out well, and I don't know, I'm pretty happy with the way this has turned out.
I don't like it. You've made a mistake.
Who said that?
It's me, the artificial intelligence inside your camera.
So I don't get it. What's the problem?
What are you going to do about those 3 holes?
What 3 holes?
Those 3 holes there.
Yeah, well, if you're that intelligent, you would realise that this 3D printed part is going to fit into that assembly and cover up those 3 holes.
What about the holes on the other side?
Well, again, when you turn this over and you fit the riser on top there, it's going to cover up Oh, what the f***? Geez, you're an idiot, Mark. Well, clearly I had a lapse in concentration, and because of Miss Smarty Pants, the camera, I had to go and make these little brass plugs. And they can be pressed on from the inside through those 3 holes there, and then I'll silver solder over on the outside and sand it off flush. So there you go. You happy now?
That's better, but you really should plan these projects more carefully.
Right, that's it. I'm getting my other camera.
Now, there's no need for violence.
Right, let's do it old school. At least you won't talk back. Well, that's the end of today's episode. Thanks for joining me. When we come back next time, I'm going to finish up all those fabricated parts, get them all trimmed and semi-polished. I'll fill up the holes that aren't meant to be there. And then we'll make a start on the brass casting. So there'll be 4 altogether. They'll have cores, and I'm going to try using some K-Bond sand for those. So that should be interesting. But for now, I'll sign out and I'll catch you up with you next time. It's Prezzo. Cheerio.
Please, I promise I'll be good.
Yeah, well, shut up. You're nothing but a jumped up Polaroid.